So in the last video, we talked about what happens when the prevalence of disease changes. And so that has an impact on some of the testing qualities, but it doesn't touch the sensitivity or the specificity. Now I want to show you a situation that does impact the sensitivity and specificity of a screening test. And so what I've done is I've drawn here two groups of people. The black line over here on the left-hand side represents people who do not have that detectable preclinical phase of disease, and over here on the right-hand side are the individuals who do have that detectable preclinical phase of the disease. And we're assuming that these are actually the yeses, in other words, yes, and the no. So even though some people may end up testing positive or negative and they were wrong, these are the true yeses and the true nos. Now, one thing that you'll notice, and I actually put them a little bit on a staggered scale, but they really kind of represent the same thing. This could be like a person's blood sugar, could be some other measurement as it's going up. This number is supposed to correspond here to the same scale, and I just staggered them, and you'll see in a minute how this will make it a little easier to see what I'm going to show you. But this value right here is the same as this value right here on that particular scale, and so they're just offset. So the thing that I'd like to show you is that for a lot of things, we actually measure it, that clinical measurement or test or whatever it is that we do, we measure it on a continuum. But then what we end up doing is we decide on a particular level to be the cutoff where we decide this is where we're going to call above this, we're going to say the screening test is positive. This positive screening test, and below this we're going to say the screening test was negative, because we have to do some kind of cutoff. We have to say, okay, a blood sugar above this or a blood pressure higher than this level, that's where we're going to call it. Now the thing that you will notice is that the way I've drawn it, this group, and I'll put it in orange, this group over here on the right are all the people who do have the disease, so they're the yeses, and they ended up with a positive screening test. So we were right. We captured those correctly. That correlates to this top left corner, of the box right here. They have the disease and they ended up with a positive test. Now, there's another group that we did a good job, yay, and that's going to be, and I'll just do them in black, that's going to be this group over here where they do not have the disease, this detectable preclinical phase, and so this is a no, and we classified them as a negative test. And so, hooray, we did the right thing. That's these people right here. Is the 171. We said, okay, no disease, screening test is a negative. So we were correct. However, there are a few people who we came to the wrong conclusion. And this is where the overlap, it'll be helpful if they're kind of staggered. I'm gonna call this group red, and I'm shading it right here. These are people who do have the disease, but their screening test was negative. Remember, the downside to that whole group is they have a medical problem that needs to be treated. We could probably even kind of keep going down here a little ways. They have a medical problem that's a real issue, but our screening test did not pick up on that. So they go away thinking that they're fine. There's another group that also has an issue, and that's this group right here. and I'll color them in green, they actually do not have the disease, but we said, you know, your test came back higher than we would like. It was above the cutoff that shows some kind of level of concern, and so we want you to go and have confirmatory testing. Remember, all of the people in this plus category go on to have some other confirmatory test because this was just from the screening test. So these two groups, the green and the red, these are our problem children, right? We want to have as few of those collectively as possible. We would like to have kind of more separation here. Now, do you remember how we had the conversation about which group is worse? A lot of times people say, and I'll draw this just so that it's kind of opposite. A screening test should be sensitive. So this screening test that we're doing, we should have it be adequately sensitive to pick up on all of the people who are the yeses. The confirmatory test that's the one that can be specific. And so that's the one that we can actually afford to be. So here's the C of confirmatory and the C of specific. So a screening test, by nature, we want to try to pick up on as many of those yeses as possible. So here we are. How would we do that? And so I'm gonna change this cutoff value. I'm going to move the cutoff value to the left, and I'm going to draw that new cutoff value here, just to be a little bit over exaggerated. So here we are. And guess what? If I move that cutoff value down that much, I just picked up on, like, let's say this ends here. I just captured every single possible case. So my sensitivity in that case would be equal to 100%. But guess what I traded for it? I just traded all, and I'll just kind of scribble here, I just traded it for all of these false positives. Those are people who do not have the disease. They ended up testing positive. Remember, now all of my positives are here, and all of my negatives are here. So all of these people tested positive, but we were wrong. These are people who don't have disease. And so this whole entire group right here, over here, they're all going to go have confirmatory testing and go through all the pain and heartache of that waiting period and all that stuff. So by moving this cutoff down, we just decreased the specificity of that test. We increased the sensitivity all the way up to 100% by moving it below the bottom person. And so that's the downside of moving that cutoff value. We try to find a sweet spot where we're not missing too many. Our sensitivity is high enough to be considered good, but we're not capturing too many of those false test results. The opposite can also be true. So let's say we say, oh, well, it's just a terrible thing to have these positive test results that were wrong, the false positives. And so what if we actually move this line over here to the right? We're gonna try to avoid having any of those, and so we move it all the way over to here. Guess what happens when we move the line all the way over to there? That's where we miss out on this whole group of people right here. Let's draw it again in black. This whole set of people who do have disease, we missed out on them on this screening test, and we don't want to do that. They could benefit from getting into treatment early. That's the whole point of doing a screening test, is to pick up on people early before they have the symptoms and before their disease progresses and gets worse and worse and worse. And so when we move this cutoff value to the right, we're trading that off. And so it's important. Here we have a bunch of negative tests. Remember, here's our positives, or positive screening test. Here we have a negative test, but they were wrong. These are false negatives. I should draw it in red. False negatives. So it's a negative test. See how that's a negative test, but it was incorrect, and so that's a false negative. So this is that whole trade-off. If we move the cutoff value, then we end up deciding at what point do we feel comfortable with this balance, this kind of balance between having a few false negatives and a few false positives. Where's that sweet spot where we can sort of maximize both our sensitivity and specificity? And so that's the conversation around what does impact sensitivity and specificity.